Okay, we are on top of the hour, so I think we can start. Welcome everybody to this core working group session at IETF 112. I am Marco Tiloca, my co-chair is Jaime Jimenez. And we assume people at this meeting have read the documents discussed today to better contribute and be engaged in the discussion. The not well applies, there's next slide for that. And we are using Miteco, so the list of attendees is compiled automatically. I'll keep a look at the chat, and two people volunteered to help taking notes, Christian and Joran. Thank you so much again. And this is an official IETF meeting, so the not well displayed in this slide applies. It's about IPR, patents, and so on. It's very much about anti-harassment procedures and code of conduct. So be nice and professional with one another. Yeah, if you want to interact, you can raise your hands with the raise hands tool on the top left section of the window, the first button from the left. If you can talk in your environment, just type my colon followed by your question or comment. We'll relay to the room. We've been recording already and up on YouTube in 1 or 2 days. Again, blue sheet compiled automatically by Miteco. So this is the agenda for today, and following an introduction from the chairs, we'll go through 4 working group documents and 4 individual submissions. And we start with href and Coral presented by Karsten and Christian. Then we enter into group communication and OSCORE territory. We have ESCO presenting group ComBis. I'll give an update on group OSCORE. Then we have the key update procedure for OSCORE on Ricard. Christian has updates on cacheable OSCORE. I'll give an update on OSCORE capable proxies, and we conclude with a brand new draft about a co-op option for performance measurement, and 10 minutes of flex time also. Does anyone want to bash this agenda in any way today? Fair none. So let's get into the document status. We always have good news of this kind. Was mentioned at the latest interim, but just to bring it to the main IETF session, since July we got published 1 more RFC. 9100 was SNML versions. Thank you very much to the authors and the working group for yet another achievement. And along the same lines, in the past months, we got approved 2 more documents for publication as proposed standard. They're also in the RFC editor queue now, where they joined 2 more documents, also waiting there for echo request tag. So there shouldn't be any more blocking conflicts in this respect, and these 4 documents should be published in the relatively near future. We also have 2 of the 4 CoreConf documents in ISG processing now. We got very good reviews from the ISG, and the authors are now processing the comments, very well tracked as GitHub issues and discussed in dedicated design team meetings occurring bi-weekly. We have next one early next week. And those are Young Seabor and Sid. And then to mention some post-working group OSCORE document, it's about the other 2 CoreConf documents, COMAI and Young Library. They're a bit in the background now to prioritize the first 2 ones I mentioned. And once they are done, authors can focus a bit more on these ones too. There were just some open points left following the Shepherd review, I remember. And finally, we have Group OSCORE that in fact, had the first working group OSCORE earlier this year, and the second from last version addressed those comments, but this latest version published before the cutoff addressed also some more points remaining open, and this is also approaching a second working group OSCORE. A few heads up on things to come, as also suggested by Francesca. The chairs plan to have an update of the working group milestones on the entry page of core in the data tracker, and some milestones have been pretty much met in the past months or even years. And it's good to add a few new ones to reflect ongoing work, and especially documents that at some point next year will be shipped to the ISG. Karsten.
Yeah, there was a, a question by Christian a couple of hours ago on the mailing list whether we shouldn't maybe have another of those core applications meetings. And I said, maybe not this week because that is already pretty full. But maybe it's actually worth trying to do an interim before 1 month's time. So specifically to talk about these applications things, because we don't have much, apart from Coral, not much applications-oriented stuff on the agenda today.
Yes, it might work. Just quickly thinking on December 1st. I would just like to synchronize a bit better on that and what to cover with that during this week, even on Gather Town. I think we can do that.
Okay. Second observation. A couple of interims ago, we decided it would be too much work and really not necessary to recharter. And now there's an interesting rumor circulating that the fact that we are not rechartering means the working group will be concluded next week. I think that's a rumor we all can work to dispel.
Yes, sounds very new to me, at least.
Okay, just wanted to mention it.
Thank you. Any comment on this first part, Francesca, or anyone, by the way? Jaime?
On the rumor, I have no idea. First news I hear as well.
Yeah.
On the other stuff, on the problem details and pops up. So I would like to have perhaps before an interim, because in an interim it's nicer to present something and show progress. So it would be nice to have first perhaps a work meeting with the co-authors. So providing that we have it within the month, we could have it then the interim also within the month. And I agree also with Marco. Maybe we can have something informal on Gather. Yeah, sorry, Karsten.
Yeah, that's okay with me. We don't really need the heft of an interim. We don't need the 2-week wait time and so on. Maybe we should just schedule a meeting to do this.
That would work better for me, at least.
Thank you.
Other document authors can comment also.
Okay, and thinking of, already scheduled thing, as agreed at the latest interim before the cutoff, we are going to have one on December 8th. It's a Wednesday, usual local time, and then an actual regular series will resume in January, every other Wednesdays, same local time, alternating with CBOR as usual. Any more comments, anyone? Okay. This actually concludes the share introduction, and if there are no more comments, we can move on to the first document. But maybe Karsten has a comment.
No, I just wanted to start with the first document.
You're welcome.
So are you showing the slides? No, I'm showing the slides.
You can take over now.
Now we are doing the game how to find the slides in the weirdly sorted list. Okay.
Thank you.
So I wanted to quickly report on the work on the draft that is called href, but that actually standardizes what CRIs are. And I have 14 slides, 11 of which you mostly have seen, so I will run through them really quickly, but please do stop me if there is a need to discuss something. So just as a quick reminder, the core group really tries to do the web of things, even if we didn't call it that way. And the web, of course, has three things: hyperreferences, transfer protocol, and representation format. And moving this to devices means we did a new transfer protocol. We did various representation formats, not just a single one. Well, we stuck with the hyperreferences which are there in the web. And that probably was a good thing to do for the first 10 years or so. But maybe we actually want to do a little bit of a cleanup now and see whether we can have hyperreferences that are a bit easier to operate on in various formats. So we're trying to pair the URI format, which of course won't be going away, with a concise form or constrained form, the CRI. So one reason is actually that URI is really widely implemented. Most of these implementations are really bad and have mistakes and so on. So some features that URIs ostensibly have don't actually exist when you look at the implementations out there. So just to remind people what a URI is, it has 5 components: a scheme, an authority, a path, a query, and a fragment. And these are single items like scheme and fragment, or they are actually structured in some way. So the authority is often a DNS name, which is structured by dots. The path is structured by slashes. And in CoAP, we decided to structure our queries by ampersand signs because that's the existing practice in the web. And there's also something called URI references, which are used together with a base URI to have a short way to talk about a UI that is close to the context that we are currently in. So you can say something like foo, and then you take the existing UI, the UI you are at, and remove the last path segment, put in foo, and so on. So this also should be standard stuff. Now, what does a CRI do? It's essentially a representation format for the URI data model, which is really interesting because nobody sat down and actually defined the URI data model. So we essentially have to reverse engineer that, and one of the contributions that the CRI document in the end will provide is a much clearer expression of the data model underlying URIs. So the draft called href defines CRIs and CRI references, so these relative things that you use when you have a defined context. So this work started a while ago, but was started by Klaus Hartke, and Jim Shard had some pretty good contributions in this space. The format is now CBOR based, and the short form, the abstract content of the draft is in the little piece of CDDL here. So you have something that ends with a path, a query, and a fragment, which are all 3 optional. And you started with a scheme or authority, most cases of which are absolute URIs, or with a discard number, which are relative URIs. So then there is fine print here with optional port numbers and so on. So this was moved around for a while, and then with -06, we finally ran into one problem we hadn't solved yet. So with URNs and similar structures, which include the DIDs, which are popular in certain parts of the universe, you don't necessarily have a leading slash, so you have to have a way to indicate that, and we found a way to indicate that by putting true in the place where normally an authority would be. So this gives us a nice way to essentially have a fully parsed URI. And the last thing we essentially changed in 06 was to parse the host name as well. So tzI.de becomes an array of 2 elements, tzI and de, and there is a port number down there in the example. So we put the port number there as well. So this has got a little bit of fixing. So after 06, they came in 07 and then in 08, sorry. And we now have something which I think can be called a consistent design. We think we are feature complete with respect to RFC 3986 in the form that CoAP actually supports, and I have a slide on that in a minute. We have some initial test vectors, and we need to update those, but it's already looking good. The implementations seem to work together. Few updates are probably needed in the implementations as well, but by the end of the year, we should have implementations that actually work together. So from my point of view, we just need a little bit more implementation and implementer reviews, and then a working group last call. There are two questions that I think we should think about. One is a pretty popular way to treat URIs in documents like document formats like JSON-LD, where you put a URI prefix into one place and then from a different place reference this prefix either explicitly or implicitly via add context, and concatenate and give the rest of the URI and concatenate that to the prefix given. And as they are right now, CRIs can only do this in certain places. So for instance, if we have a scheme and an authority, we can put a path after that, and CBOR Pact can handle that nicely. So we don't have to have any special mechanism. We can handle this within CBOR Pact. But it becomes difficult if the URI, the prefix URI, goes on into a partial path and expects the referencing side to actually put in the rest of the path. And of course, the first place where this becomes very obvious is when you look at W3C Web of Things thing descriptions, because they use a prefix, an add context that has two elements of a path name. It's under w3.org, and then it has two elements, NS and TD, NS for namespace, TD for thing description. And then it expects that you provide the next path component. And that is difficult to do right now. CBOR Pact doesn't provide you a form of prefix compression that would enable you to do that. So this is an area where we have functional deficiency, and we currently don't have a nice idea how to fix this. There are several not so nice ideas how to fix this, and this probably needs a little bit more thinking. Of course, we can leave the functional deficiency in place, or we can address it. So this is one thorn in our side. And the other thorn in our side is that CoAP has decided to not support percent encoding in URIs except for the specific case that CoAP's own, or the CoAP UI's own delimiters are escaped by the percent encoding. So I think that that's a reasonable thing, because percent encoding means you have to do string scanning and copying and all that stuff, which you don't want to do on a constrained device. So when CoAP sees a path %2f / foo, then the URI to CoAP conversion converts the %2f to a slash. So that slash is part of the path segment and not a delimiter between path segments, and everything works like it should. But that doesn't work with W3C DIDs, which we probably have to support in some way. And we had a meeting just last Friday where we discussed this, and we're a little bit unhappy with the situation that we cannot really express all potential DIDs using CRIs. So yeah, we thought a little bit, and there is a pretty easy fix, which maybe is a little bit easier on the specification side than the implementation side, but it's not that bad. Where all the text strings that are used in URIs have an optional form in which they alternate unencoded and percent encoded parts. So the BB %3AC that is up there in the example, in the UIN example, which would look similar for a DID example, that is a colon that actually is not used by the URN internal syntax, and that may have been registered as AA by someone before. So there's no way a generic processor is going to know what the internal syntax of that URN is. So percent encoding may be needed to escape things that need to use the same delimiters that are used for the internal syntax. And the idea is to allow, instead of the string, which is AA:BB:C in the second last line, to allow an array there, and the array is structured in such a way that the odd numbered elements are actually percent encoded, but they don't need to be percent encoded. There's no need to actually do the percent encoding. They can be fully processable by the implementation, except that they have the special percent encoding syntax, so they would not be used by a string scanner that looks for colon delimiters in the URN syntax. So it's a little bit like indefinite length strings, the kind of processing that you get into, except that the elements actually mean something slightly different. And if you are scanning for delimiters, you just leave out the odd elements. You only scan in the even numbered elements. So here we have a proposal. And now, of course, it's a matter of design taste, whether people think this is a proposal we can pick up, or whether this is just too ugly. But not picking it up, of course, would mean that we don't have a way to do all these cases of percent encoded URIs. So yeah, I'm not. Well, I'm happy that we have a proposal. That's a good thing. But I'm still not entirely convinced myself. But I think if we actually do want to support percent encoding in some form, this is by far the simplest way to do this. So everything else one can come up with is even uglier. So that's the two things we may want to think about before we go for a working group last call. Comments?
Christian Amses, I'd like to point out that the alternative to doing these percent encodings and other things that we might need to do to get full feature parity is to just admit URIs in several places where CRIs are acceptable. And it will be something that we'll need to work through also in the design team, but also solicit input here, that this is just the easier thing to do for the general case.
Which means that you have to carry around both a CRI and a UI implementation.
Yep, whereas doing these percent encoding tricks here and some other mean that you might have to go into a URI anyway, because processing it out of the separated form, if you have semantics in there, might be comparatively tricky too. I think we should just keep an open mind towards both solutions while we're exploring them.
And from the chat, Hank is overall supportive of somehow taking care of the ID support. You have any preference on the exact solution, Hank?
No audio.
Mumbling to mute. So this is, yeah, of course, it's tricky to encompass them all. But my suspicion, and maybe my hope, is that when we try to support the majority or the host of it, in the end, the weirdness of how they're constructed today might be contained a little bit, and then the CRI could be the guidance how you would do it, and that might ease the wildness out there a little bit and calm it a little bit down. So I think the effort of trying this is warranted. I understand that, of course, you fall back to URI if nothing fits, but in the end, maybe that's something we can make go away over time.
Yeah, basically the idea in the CI draft was to actually document which UIs are not supported, and there are still some very weird UIs that are not supported even with this percent encoding fix. But I think they don't have much practical relevance, while the percent encoding is actually being used, even if we know that implementations usually are really bad in this space. So they probably won't be correct, but they probably will at least cover like 80% of the cases that actually do occur. So it would be a drawback if we couldn't support those. But it's probably the one place where I would say that might be an optional feature in CRIs, because you don't actually need it unless you have weird UI designs or weird server layouts.
Thank you. Any more comments, anyone? Okay, now, thank you for today, Karsten. And next is Christian with Coral.
Hello. Like Carsten did, I'd like to go through a bit of introduction of what Coral does, because it's been a while since this has been presented at a full IETF meeting. Coral is a data model and a language that allows us to talk about resources on CoAP, on other protocols, and on how to interact with them in a way that is suitable for constrained devices. That is similar to how CRI fits into this fits into the analogy of having a constrained device processable format for URIs. Here we have a format that covers areas of metadata. And this, before I get into kind of the concrete formats this could replace or is similar to, we already have a few users that would want to use this. So the first two documents, problem details and PubSub, are in this working group. Group management and administration is in ACE, which would be a bit simplified if built on Coral. SDF might have applications that we're still exploring, and basically anything that so far uses link format could just as well build on Coral. But it's not precisely the same. So for example, going ahead for link format, RC6690, this had a lot of string parsing. So like we had before about processing a URI byte by byte and looking into what does this mean semantically. In Coral, all the information that in link format is there by possible escaping of strings and processing parts of a URI out of it. this is all expressed in CBOR. But then again, compared to CBOR, we have semantic information there. We have properties of resources that are tagged with that are described by predicates quite similar to RDF, which allows us to use several domain languages in the same document. So we can, for example, extend, say, a pub/sub broker that uses terminology originally designed for pub/sub with application-specific semantics that are ignored by processes that are unaware of that application, but can be used to augment functionality. So terminology can be reused when building an application on top of Coral, but it doesn't. Terminology can be reused and lost track. And doesn't need to and there's no need to define a fully custom format based on the old terminology, but things can just be mixed in a single document. Compared to RDF, to which this is also similar, especially in the data model, this is processable by constrained devices. There's no URI process that you need, and it's quite compact. So just as we do in co-op with using option numbers, here we can express all those predicates that are conceptually URIs that describe the relation between the thing that we describe and the data we described with, is encoded in numbers rather than, or is expressed in numbers that encode for URIs. Still, all of those are similar. So RDF and RFC 6690 link format have now, in the latest version, defined conversions back and forth, at least for subset. Without the RDF, the exceptions are relatively minor. With link format, it's a bit, it needs a bit more thinking. Link format can only be converted to Coral, provided the application uses the semantics that we use in core for the attributes, because otherwise the values of the attributes in the link format document are not necessarily well defined or registered anywhere. So it's up to the application to define what the attributes mean. If the common attributes are used, there is a conversion back and forth between Coral and RFC 6690 defined, at least for the subset of Coral that can express 6690. With CBOR, it's relatively straightforward. Coral can express literals, and these literals are just the ones based in CBOR, because Coral is encoded in CBOR. So you can just use basically any value of the extended data model and put it in there. We've been meeting regularly in design team meetings and processed a few, focused on a few components that we thought that we better make progress fast. One of those was the information model. This is now, I think, almost complete. The information model is now twofold. There is the very RDF-ish basic information model that just describes what is encoded in the file. And there is the additional structure that can be put on that information that describes how this is laid out in the file, so that a consumer, a constrained device, can process this without building the full graph and traversing that graph, and instead traverse a much easier tree. The interaction model didn't change too much. This has already been in a very good shape a few versions ago, basically describing that there is a user agent similar to a web browser that hops along this graph or tree, may need to fetch a resource that it encounters, gets information, gets a representation of that resource that is typically a Coral document again, find that there is a link or a form that it knows to be able to follow, perform that until the program terminates or reaches a state where it waits. We've changed a bit compared to the version that was presented a year ago, how the dictionary is precisely defined. Now CBOR has, at least as an adopted item, the packed CBOR format that reserves a few CBOR tags that can be thought of as compressions of larger CBOR items. And this This is basically what Coral has been doing for a long time, but now instead of using integers, we use those tags and all the defined semantics for that. What is not clear there yet is how we will set up the dictionary based on which the compression happens, because it's not like gzip or zstd or whatnot that ship all the dictionary in the file, but the typical situation, especially for things like link format-ish documents, will be that the document format is declared as a media type with a parameter that is all compressed into a single content format number. And the consumer, seeing that number, will know to pre-populate all the dictionary with the typical items like resource type, core interface, the hosts relation, and all those things that are common in link format documents. We might also want to use basic packed format, which is packed CBOR's way of defining that dictionary at the front of the file. And we might also consider importing a named dictionary that is, you state one URI or one URN, and the application then loads a dictionary associated with that name into the current state. Which of those we take will probably be guided by applications that we try this out on. The binary serialization, we didn't change a lot. This is just something that we'll also leave to a later stage when we have a corpus of example cases where we can then evaluate, does it make sense to spend a byte here or spend a byte there? But this is best done with a larger basis that I'll come to in the next step. We'll have to obtain. There used to be a text serialization that was very similar to Turtle that took up a large portion of the document, and we've removed that for the time being. Expressing CBOR in diagnostic notation expressing Coral in the diagnostic notation of CBOR is now a bit easier now that there's the EDN, extended diagnostic notation draft around, which allows us to just write CRIs in text URI representation. And occasional examples are also expressed in Turtle in those cases where we just need the C of triple semantic and not all the structure that is in the tree shape, or when we don't need to express whether something is written down in packed format or just spelled out. And there is the topic of how we do queries around this, how we modify a document, like can we use this with fetch or with post, and how we describe where the data comes from, which is related to reification of those statements, that is making them into something that we can later talk about having come from this or that authority, which is very important to have, but we're currently just chunking it up. We're keeping those things in mind, but they are for later phase in the specification, and some of those we might also defer to a second stage when the basic model is already done. So our next steps are to coordinate with users with potential users of Coral and just check whether what we're doing is still aligned with them. This is relatively easy for things like problem details, where we're already using those documents for examples, and aligning this with IETF will hopefully give us a bit more insights, because we don't precisely know how things like forms are used there at all. From that, we hope to get a corpus of items that we can then try the binary serializations against, and also evaluate which steps in the dictionary setup we need. Something that we could probably use working group input on right now is defining the subset of features that we want to have right away, especially when it comes to things like patching or fetching. Is this something we should aim for in the current iteration, or is this something that would be okay to ship as an update? Yep, thanks for your time. Are there questions? Do you have maybe have comments right away?
Yeah, I see no in the chat either. Ari says this is good stuff. Indeed. Okay, if there are no other comments or input from Christian, thank you so much. We move on with the next item. That's ESCO for group communication for co-op. Hi, ESCO. We cannot hear you, but we can see you.
Okay, I just need to unmute, so it's okay.
Better now. Yes.
Yeah. Let's see.
So,
Got the slides.
right.
So maybe you have to remind me again for the slides. So you
Look on the top left, the second icon from the left, so the PDF icon, and then you have to select the right one, but you can have also preview in the selection window.
Okay, and I need to do it, right?
Yeah.
Let's see. So your presentation view, that's not the right icon there. Oh, that's the, yeah, okay. Ask to share slides, is that the one?
Yes, yes,
okay.
And it's loading.
Yeah. Okay, I see it at least now.
Yeah, it works. There you go.
Okay. So I'm going to talk about Group Combis, now at version 5 already. And let's briefly recap the goal of this document. So I'll make it shorter than last time. So we actually have working on normative successor for RFC 7390, which was experimental and addressed co-op group communication. We obsolete that predecessor RFC and also make some updates to co-op and observe. And the idea was to have a new kind of standard reference document for group communication that also implementers can use. The scope, we cover various things all around co-op group communication. So not just over UDP, over IP multicast, but more in general now as well. And also mention latest features like observe blockwise and of course security. That's also a major part of the draft. So we now define group OS core based security besides the unsecured co-op group communication. There's also now a bit more extensive definitions of the group types and how they relate to each other. And also some guidelines for a secure group communication. So now I'll go into a quick overview of the updates we did for this version. So the first thing we did was remove the multi-ETAG option. So at some point we introduced the existing ETAG option, which seems okay for the purpose and is also simpler because it's already there and it has a simpler structure. And to us that seemed enough. So we don't need necessarily this multi-ETAG option. The second point was that a whole section was added, 1.3, based on the review comments to clarify in more detail what we actually update or obsolete in the former RFC. So this is now all kept in one place in this section. And also a change was made in section 221. So this was about how you basically can identify or name an application group within the group URI or more general within the co-op request. So we put this resolution for this issue, also 28, in the new version, but it's still pending some working group review and approval, of course. So now I'll just move to that. So this is a little bit of an intermezzo where I introduced this issue, 28, application group naming. So what we have defined in the draft is the application groups that could be named with any identifier, such as a string, a number, integer number, or complete URI. If you have such identifier, it may be encoded within the group URI. So this top form is what we basically recommend. It's kind of a usual way to do it. So you have here in the authority, there's co-op group address. That's basically the co-op group to which the request is targeted. And within the co-op group, you can have multiple application groups still. And this is group 1 shown in red here in the path. Of course, you can encode that same information also in other ways. So it's also shown how to do that in the query in different ways. You can even put it in the host component. In that case, it becomes a part of the co-op group, because the co-op group is composed of the authority, including the port. You can also put it explicitly in the port number, so then the group application groups becomes a number. In that case, it is also part of the co-op group, because the port number is also included in co-op group. So there's some overlap in that case between what is the co-op group and what is the application groups. But these are all ways that the receiver can at least identify the group, but also the sender can identify it within the URI, which is still not yet encoded in co-op form. This is just the URI as such. And the final option we show is that it can also be not in the group URI. So you can also say, well, the sender adds this, for example, in a co-op option, and adds that to the request, which is not something that's not part of the group URI, but is still in the request. You could also have it implicit, so that means that the receiver has to figure out what is the application group, or there is just one default application group in that case. That could be associated to that co-op group. So this is the part we clarify a bit more. So it was not so clear from the previous version of the draft that we could actually do all these things, and all of this is of course application dependent. How you exactly encode this, you can do many different things here with co-op. Okay, we'll just continue now with the updates. So 3 more updates we did. Was in section 2.2.3. We also had another open issue, so that was also based on a review by Christian about what kinds of group discovery are possible using co-op, because we mentioned there is RD, group discovery, and we mentioned there is also discovery of groups you can do with pure co-op, so client to server, without using an RD. It was not so clear what this really was and what kinds of group discovery are possible. So now we expanded this text here. Also make some examples of what you can discover with basically co-op discovery and link format. This is also pending working group review and approval. The second important change was the second point on the slide. So we have stronger advice on unsecured group communication. So now we just say in capitals, it's not recommended. And this was one of the open issues, number 22. So we hope that's okay for the working group to have it as a normative statement. It's still possible to do it, but if you have ways, of course, to protect it, then that is definitely recommended. Let's see, I see a hand coming up.
Yeah, I just have a quick question. When you say not recommended, does this mean that we are essentially deprecating the use of multicast for discovery?
I think multicast for discovery was, I think, mentioned as one of the cases where you often you do still need it. So
Okay.
I think Marco, that's correct, right?
Yes, we are basically saying it's not recommended. If you do otherwise, you'd better have very good reasons and analysis of your case, and early discovery is one example we gave.
Yeah, I think this discovery needs to be qualified a little bit to reduce the potential for reflection attacks. So you should say something that if you use it that way, make sure that the response is not much larger than the request. But of course, that also doesn't help if your multicast group is gigantic. So yeah, it would be interesting to see how we actually position ourselves with respect to that usage, because it certainly was very popular when the work on CoAP began.
On this point, Carsten, following John's review, we also added in this version more content about the risk of amplification attack.
Thank you.
So that's discussed now also, more than the previous version.
Good.
Thank you.
Okay, yeah, that's right. And yeah, then finally, that's the kind of catch-all improvement. So we made some editorial improvement and fixes. So there were some fixes in the description of the group relations and the diagrams. We expanded explanations of forward and backward security, just to make sure that it was clear what that meant in our case. Also, the text that Marco mentioned about amplification risk is also more extensive. All right, so I think these are the main improvements. So I want to go back to this top one, so number 29, just to give an overview what this was about. So here are some CoAP multicast queries that you can do. So a multicast request, that's basically doing a query on .wellknown/core to discover something. And of course, all of this is very much application dependent. There's no single way to do this. It depends how if and how the groups are encoded as part of resources on service. So in this case, we assume that application groups are represented as resources. And also these resources in the top example are located within a specific path, so /g/something, and then that something is the group name. So basically this sends a query to the CoAP group CG1, which could be a URI that's resolved to a multicast address. It could be just a plain multicast address and port. So this goes to all the CG1 members. And these members will basically be queried for application groups. So, and with star, we basically have a wildcard. So any application group name should match here. So the idea is that these application group members then will be reporting back their application groups. Let's see, then the second example, that's sending specifically a multicast to the realm local CoAP group of all CoAP nodes. That's this FF03FD address. So there it's querying a specific group. So this is encoded in a /group parent resource, and a /group1 child resource is in there. So it will basically find this specific named group, or all, including all members of that group who will be responding. Let's see, the third example is to have application groups of a particular type, again in the local mesh. So that's the FF03, it's multicasting to the realm local address, local mesh. So this type is now encoded as a resource type RT attribute here in this particular example. So the client knows that and will just query for anything with that RT to get these these specific types of application groups back. And there's one more example of this in the IDE. So this is not exhaustive, of course. This is just to give some examples of how you can use this for discovery of groups and group members. So both for application groups and CoAP groups. Question, I see, Jaime? Did you have a question?
Yes, well, more than a question, a clarification. So all of these examples in the presentation are excellent. I'm just trying to look for them in the document, and it would seem it's missing some examples, so it could benefit from them. I haven't done a thorough review, so I apologize for that to begin with, but just a comment.
It's true that they are in text there. Maybe it would help to also have these example URI. So these are a bit more specific than what we wrote down, I think.
Yeah, maybe like these classic request response examples.
Yeah.
That will help. Thanks.
Okay. Yeah, that could be helpful there to maybe add as particular examples. I know we have some text, and you could have a request response type thing added to that. Okay, that's definitely something to consider. Yeah, that's fine. And let's see, we can go then, I think, to the next steps of this. So what do we need to do? So I think what would be helpful is some more reviews of the updated parts that we had in the last draft. If all that is well, we can close these issues, maybe extend the examples a little bit more, like we just discussed. Now, question is, do we need more reviews of the entire document? I copy-pasted here the promise from IETF 108. So we have here Christian and Francesca as reviews. Christian actually did a review because we got at least a couple of comments from him. So I'm not sure if you wanted to do more than that. But okay, I just wanted to mention that.
I most likely won't have time to review this before it gets to me after working group last call. Sorry about that.
Okay. Yeah. Okay. No problem. So the question was also, we can also do this as part of working group last call that we started, and then this could trigger another review, for example. I think the previous review comments, so there were a lot from John and Christian, so thanks for that. These are now addressed, we think at least. So that's why we believe the version 05 may be ready for the working group last call now. Okay, and that's it for this time. Thanks for your attention. In case you have some questions, let me know.
To relay from the chat that Christian will have another look too.
Okay, very good. Yeah, can see if we solve the issues in an understandable way, basically. Yeah.
Any more questions, comments to ESCO? Okay. Thank you then.
Thanks.
We can move to the next one, which is group score. All right, this is an update of the group score document. We have submitted version 13 before the cutoff, and the version before that was indeed a major revision based on comments from working group last call and some follow-up comments. In comparison to that, this version comes in with much simpler updates. And to start, we updated the terminology to be aligned with what the ad hoc draft in the Lake Working Group is doing in naming public keys as possible credentials. So now we are referring to CCS. So it's sufficient to refer to RFC 8392. While proofreading the draft again, we noticed there was an oversight when defining the key derivation of one particular key, the group encryption key, which is used to derive a key stream for encrypting the signature in group mode. So that is fixed now, and it was about the exact key size of that key, which is exactly the same key size used by any other symmetric keys for the encryption algorithm in group mode. So that's also fixed. Other than this, the major update in this version was instead some more specific text about what is mandatory to implement. There was an issue that John opened about this, I think even 2 years ago, and thanks to this update, it's also resolved now. It boils down to what we can expect constrained devices to support, especially when it comes to this signature algorithms and companion key agreement algorithms for the pairwise mode. And we are fundamentally taking the same rationale used again in the ad hoc document in the Lake working group. Adapted to the group score case, it reads pretty much like this. For the sake of the group mode, we expect non-constrained devices to support both the EDDSA algorithm and the ECDSA algorithm, while we expect constrained devices to support at least one or the other, at the end of the day, to support as much interoperability as we can reasonably have. Just as a parallel thing, the pairwise mode follows the same rationale, so that we expect non-constrained devices to implement both key agreement curves and constrained devices to support at least one. And this can probably be relieved and live better in the near future as more algorithms are supported also in hardware, but it seems a reasonable thing to do for the time being. And that was it about the updates to this version. And some of the still open issues were actually already addressed in the previous version 12, but we waited anyway, considering that we had these small points to still close. So at the moment, we are not aware of any other open points or issues. And we have also updated our implementation for Californium, aligned now with the latest version 13. So we believe this version 13 is now ready for a second working group last call. And independent of that, we are also starting producing test vectors, taking as a starting point the ones of the OSCORE RFC, but we expect these ones to be a bit longer since we want to cover the group and the pairwise mode, possibly the combination of the different signature and key agreement algorithm. So no need to find an answer to these questions now, but just to raise the point that at some point we'll need to decide where the best place should be to have test vectors, because probably they'll be too long to be included in the main draft. It can certainly start as material in a working group repo, but then we can possibly consider what is happening about test vectors in the Lake working group, meaning it can be a separate informational draft. And if so, we can think if it is also worth specific publication. But I just want to raise up the point for the time being. We are on test vectors. And Göran.
Hello, can you hear me?
Yes.
Yes. So how is the thinking on lining this draft and the draft in the previous presentation? Are we going for independent working group last calls? And I mean, at some point they will align, I suppose, since this depends on the other.
So content-wise, they are aligned and both mature, I believe. I think it's easier if they proceed to working group last call in parallel. Certainly, it's easier, I believe, for the ISG to receive them together.
Okay, fair enough. And the other draft was also about to come to its first working group last call, or?
That'll be the first one.
Yeah. Okay.
I quickly saw Francesca in the queue, but...
Yeah, I just want to say I will move them forward together when they reach me. Yes.
Yeah, that's all from my side. We think this is ready for consideration for a second working group last call. Any comments, questions? Okay, I see none in the chat either. Then we can move to the next item. Oh, Jaime.
No, I was just going to say that maybe we can start the second working group last call already in the mailing list this week, if that's okay.
Works for me.
All right. I think we can do that. How long would it take to have the test vectors ready, by the way? Do you have an estimation?
Yeah, probably it will take a while before having a full set, but I hope by the end of the year we can have a preliminary set, realistically.
Right.
But again, they are probably an overkill to be included in this exact document. See that as supplementary material, and then we can decide later on exactly how to release it in the best way.
Right. And also, could we get already in this meeting an estimation of how many people have read the current version? Maybe not the current, but the one that is a major update, the previous one, just to, you know, see some participation there. Don't know what is the right way to do it, but I think a +1 on the chat will be sufficient.
Or
If you
join the
have
queue.
read one of the last 3 versions, yeah, or you can join the queue as well, just to see how we are in the group. So I see Christian. Click card. Right, and also, I mean, for the second working group code, we would need more eyes on this. Do we have some volunteers already to have a look to the latest version? Esco? Okay. And John? Right. And for the minute takers, please remember to write the names there. Okay, any other volunteers? All right. Thanks.
Thank you. Yeah, I'm done here. So next in the queue is Richard.
Yes, hello. Let me share the slides.
Loading now.
Yep. Right. Yes, so I will be presenting this work on key update for OS Core, also now called Kudos as a short name. And these are, yes, let's start with a short recap. So first of all, what this is about, well, OS Core uses AED algorithms for providing security. And there's a C4G document, which is referenced here in this slide, which defines the fact that you need to obey certain limits in terms of key usage when it comes to amount of encryptions and number of failed decryptions. And if you reach those limits, you should rekey, because excessive use of the same key can enable breaking security properties of the AED algorithms. So basically, this draft has 2 main parts. The first part is the study of these limits and their impact on OS Core, which means, among other things, that we define some appropriate limits for OS Core, and for a variety of algorithms. We also define counters, message processing details, and practical steps to take when limits are reached. So it's about the limits and how you should change the message processing in OS Core to take this into account, which practically means counting key usage. And we also took into account, by the way, input from Jon Mattsson on the April Core interim, and we also got very recently some further input from him, which we will be taking into account. The second part is about defining a new method for rekeying OS Core, which we call Kudos now. We discussed in a previous meeting if it should have an actual name, and now we put the name Kudos. And this method is loosely inspired by Appendix B2 of OS Core. What you want to do is renew the master secret and master salt, and thus to get new sender and recipient keys, practically rekeying your context. And also this method achieves perfect forward secrecy. Going into some details and updates on the key limits. So first of all, a recap again on these key limits. So again, it's discussed in this C4G document. You need to limit key usage for encryption which is counted as the a Q parameter or the Q variable, and invalid decryptions, which is the V variable. So basically what this draft does is defines fixed values for Q, V, and L, and from those values, you calculate the CA and IA probabilities, which is the confidentiality and integrity advantage, which is basically the probability of breaking these properties of the algorithm. So what you want to see is set Q, V, and L, and from those calculate acceptable values of CA and IA. And yeah, we also added some text now. Now I go into some updates from the last version. So what we did, we added explicit mentioning of the fact that now when you send an OS core message, you have to obey the L value, which means you have a practical size limit to the amount of data you may send, since the L is basically the message size in cipher blocks, and you should not exceed that. We have some text there specifically on how you can easily calculate that. We also now, after a suggestion from Christian, have a table showing the values of L, not just in cipher blocks, but also in actual bytes. And continuing on, so what we did was we have this table where we show the IA and CA probability for a number of algorithms, and these are all algorithms except AES-128-CCM8. So basically we deal with AES-128-CCM8 in a separate table, and these algorithms are the ones that the C4D document defines formulas for. So we set Q, V, and L fixed values. From those we calculate the probabilities. And in the C4D document, they mention aiming for a probability of CA and IA that is to be lower than 2 to the power of minus 50. And as you can see in this table, we are within that safe margin. So our probabilities are in fact even lower than 2 to the power of minus 50. And so that brings me to this red line here, which says that we do intend to increase Q, V, and L further, because we do seem to have some margin for doing that, as we're still way lower than 2 to the power of minus 50 in terms of the probabilities. So there's an open question if we should proceed with actually increasing these values. And yeah, please jump in if you have any comments. Yeah, see Christian.
Listen, I think L would, if we can increment L by at least one power of 2, then full messages can fit, because 1024 byte is enough as a payload, but the whole message will be longer. So if that's the limit, it's kind of impractical because it limits block-wise to 512 byte blocks.
So you would like L to be like 2 to the power of 11?
Yes.
Yeah,
Is
that's
it
it.
in bytes or in blocks?
Now these values are, this L is in blocks, in cipher blocks.
Then scratch that.
Okay, scratch that. Yeah, we don't present it here, but if you check the draft, we do have a table now which shows the actual L value in bytes, which is then, that of course depends on the algorithm. But check that and we have an actual table showing that information. Yep, and so basically here's the table where we deal with AES-128-CCM8, because that's a bit of a special case where you need to treat that separately, because here you end up with quite a low, or I should say quite a high IA probability. So we chose custom values for AES-128-CCM8 to try to optimize reasonable values of Q, V, and L. Because if you have L to the power of 10 here, you couldn't have a very high Q or V. So here we have L to the power of 8, like you see the green arrow, which is the recommended values that we have currently settled on. And of course, here's an open question. Is it ideal to aim for a CA and IA close to 2 to the power of minus 50, as they mention as a proposed goal in the C4D document? That's the current approach we're following. Yeah, then I go into updates on the key update procedure. So we did define a new method now for rekeying OS core, which we call kudos, key update for OS core. So essentially, the client and server exchange two nonces, R1 and R2. And you have this update CTX function that you use to derive new contexts using the nonces. And practically, you start with your current context, you have one intermediate context, and then you end up with your new security context. And we also managed to get a number of beneficial properties here. As you can see in the list, so you can initiate by either the client or the server. It's completed in one round trip, and after that, you can use the new context. Only one intermediate security context. The ID context doesn't change throughout the procedure, in contrast to Appendix B2. It's also robust and secure against the peer rebooting and compatible with prior key establishment using the ad hoc protocol. Because update CTX can actually use the ad hoc exporter if your original context was built using ad hoc. And by the way, I have this red box here. So what we did is also extend the OSCORE option with a new flag bit and a field called ID detail, where we practically exchange the nonces. Some other updates we did. So first of all, we no longer include R1 in the response one for the client-initiated rekeying. And this is just like how it's done in OSCORE Appendix B2, because it's simply not needed here, as you can correlate the request one, you can correlate in response one with request one using the co-op token. So practically you don't need this extra R1 value in the ID detail. Other updates, we had recommendations now on minimum length of R1 and R2, which are used as nonces, and motivation is similar to what is written in Appendix B2. And as things stand now, we recommend minimum 8 bytes, and here's an open question if this is sufficient or not. We also discuss a bit now on observations, and our conclusion currently is that you must terminate observations after rekeying, because basically you don't have the cryptographic binding between notifications in some situations. And there is possibility to keep these by paying a price. And the suggested solution we have here is that what you can do is, if you have ongoing observations, basically after rekeying, you need to jump your partial AV and the sequence number to higher than the maximum partial AV for any ongoing observation you have. And of course, the drawback here is you have very big jumps in the partial AV, which means faster consumption and larger communication overhead. So there's also some possibility for more complicated solutions, like reserving some PIVs in a bitmap. But for now, our proposal here and plan is to not keep observations after rekeying, because you can basically reestablish the observations. And keeping them seems to have many drawbacks here. But again, this is an open question, and any feedback is welcome. Yeah, we added a use case related to 6-dish, and I see Karsten is in the queue.
If the observations are going away, this means that the rekeying event is visible on the application layer. Is that something that we should be doing?
Yeah, that's yeah. So basically, right then the application would have to probably then take the responsibility to reestablish these observations. Yeah, it's open if yeah, of course that's one drawback of terminating observations.
Yeah.
So yeah, that's.
I'm trying to understand how bad this PIV advancing thing actually is.
Yeah, so it will be basically like, yeah, as we state here in the possible solution. So right after rekeying, you would have to check the highest partial AV among all your ongoing observations. And then when the client starts a new observation, you need to jump your sequence number to that highest value plus 1. So of course it depends on the scenario and how often and much this client is using observe. But in some situations, it would mean then big jumps in the partial ID and a lot faster consumption and then larger communication overhead. So yeah, it depends, I would say, also on the way that application is acting and how much it's actually observing. But also, by the way, one thing we thought about here is I think the way we have to deal with this is that the two pairs, we basically have to define how this works here in the text, because the two pairs have to agree on what to do, and there's not really an opportunity for negotiation or choosing on your own. So it should really be stated in the text what to do with observations. So the question is then, is this drawback too big of a drawback? And secondly, are there any other possible solutions to, in such case, keep observations with some smaller drawback? So this would definitely be good for further discussions.
Yep.
Thank you for the feedback. I see Göran also.
Yeah, so just question for Karsten. If you need to update keys for some other reason, is your sort of proposal that it should not be visible to just happen, or what's the mind? What would you prefer? Sort of, would it be that this is controlled, or it just happens without any notice?
Well, the application probably should have a way to ask the security component to rekey. But what's in here right now means that each time the security component, just based on the number of messages that have been sent, decides to rekey, it needs to involve the application doing that. and that's a bit inconvenient. I mean, it's not a disaster, but yeah, you have to send all these messages then.
Yeah, you have to send, yeah. I do see Christian's.
I agree it's inconvenient and definitely a good point for consideration, but on the application level, is the loss of an observation really that visible? I mean, the application might be requesting from the CoAP stack just to get a continuously fresh representation of that resource, and the CoAP stack might do this by polling or by establishing an observation. And in such a situation, the CoAP stack, noticing that the observation goes away with a good reason, would just reestablish the observation.
Yeah, I see your comment in the chat also, Christian. So that's a good point. But yeah, this is definitely worth, I think, further discussions and considerations. Yes, I'll proceed then. So again, we added this 6-ish use case, and you can read this. I will speed up a bit, but you can read about this in the draft. But essentially, one big benefit of this new procedure is that you preserve the ID context, which is used as a pledge identifier in 6-ish, or rather, you have a binding between the ID context and the pledge identifier. So, okay. So next point here is that we now update the RFC 8613, which is those core RFCs, saying that this is deprecating and replacing its appendix B2. And yeah, just a check here if this is okay, and if anyone has any feedback, if this is okay to do. We have some more general updates, improved the table of content, some editorial improvements, harmonization with ad hoc, IANA considerations. We updated the title now to be called Key Update for OS Core. Kudos. And yeah, that's also an open question. Any feedback on the title? Now the title, of course, mostly considers the key update section of the draft and not really the limits. So any feedback on that is welcome. Then we have some next steps. Addressing some open points. We have a number of issues on the GitLab repo. We need to look at material to save to disk to support rebooting, applicable considerations from OSCORE Appendix B2, updated security considerations, and then we want to further refine the key limits, as I mentioned earlier. So we do feel that the document foundation and the key update protocol are stable. And by the way, yeah, we do have plans to actually implement this in code also. both the limits part and the key update procedure. So then we wanted to here propose working group adoption of this draft, because we feel that it's at that stage now and it's ready for that. And yeah, that's about it. Thank you. I was a bit over time, but thank you for the for listening, and thank you for the feedback.
So when you say working group adoption, you mean within this week, or even in this meeting, right? And the question also goes to Marco, which is a co-author. I'm just asking because as co-author, he cannot maybe call the working group adoption right now.
Right.
Right. Okay. So
Yeah.
right. So well, actually, well, similar process as before. I would like to know first on the chat who has read a current version of the draft, other than the authors. I assume John and others have, and I cannot see the chat. Oh, okay, Joran and Christian. And John. Right. And well, then I think we could do a working group adoption on the current call, and then take it also on the mailing list. Let me just. I'm trying to use now the show of hands tool to see. Let me phrase the title here of the question. So something like it's the first time I use this actually. Sorry for that. Who thinks the draft is ready for adoption? Right? Is that a good way to phrase the question, by the way? Who thinks the draft is ready for adoption? And then just click yes if you agree. And I guess you can also, maybe I should put it in raise hands if agree, just to avoid confusion. And you should have it on the there's a session going on. I see 7 raised hands. So just remember we have 43. It's not bad, but don't worry so much about the numbers, because in previous sessions usually like there is a small participation compared with the amount of participants on the call. 8, 9. Okay. I think it's a good show of hands. So let's keep it in the minutes that we have. I'm going to take a caption, a screen cap also. For later.
The number of Jabber and Meet Echo participants is 43. The number of actual Meet Echo participants is like 28 or 27 or something. If I remember correctly, just for information, the count here is really misleading.
Yes, I agree with that, because we have so many Jabber participants. I think, anyway, I'll end the session now. I think it's a sufficient number for, I mean, the previous documents we have adopted them based on that. And anyways, we have to confirm on the main list. So I'll take care of sending a message to the mailing list later after this. And thank you.
Yeah, thank you.
Thank you, Richard. Okay, next is Christian with cacheable Oscar.
Yep, next time I start with video and audio again so that I can speak while I'm looking. This is an update on cacheable OSCORE, which has last been presented during the interims. Today, I'd like to focus not so much on the mechanics, which are slowly maturing and basically working, but on a topic that came up during the work on the current -03 draft. which is more along the lines of what does this do precisely in terms of request response binding? So what I thought I could do, and I'll walk with you through the steps there, is split this into how do we obtain a request and response binding in OS core in general, and in particular, how do we obtain request and response binding when we do not have source authentication for the request, and then building on that, how do we obtain cacheable OS core responses? Originally, I was afraid that this would be a very, very large change to the document. I tried it anyway, and turned out that it hasn't been that large of a change in terms of text. In terms of semantics, probably it still is. So this is why I'd like to focus on this part 1 today. Just to set up the stage and the context, in OS core, we get request response binding by repeating the sequence number and the sender ID in the response, not in actual text, but as part of the additional authenticated data. So for a mismatch to happen there, and that's one of those co-op attacks that OS core is designed to prevent, the client would need to send a request R1, but the server would need to process a different request R2 that match on those details that are put into the AAD. But in regular OS core, this can't happen because the key is shared between those two parties. The server verifies that the request is coming from the client. So either the client would need to maliciously send two requests, which doesn't make any sense because it's the client that wants the binding to be there, or the server would need to lie, and the server can lie anyway because it's the authority on all the things here. In group OS core, things look a bit different. In group OS core, there is shared key material for the symmetric encryption part. So any other client other than our particular client C could have done the encryption. But there's the signal in group mode and in group mode and in pairwise mode, there is source authentication because either there is a shared key used between the client and server that only those two parties know, or there is a signature by the client. So again, the server can know that the request was originated from the client, process that information into the response, and then the client can understand that response knowing that the server knew who sent it. But this also means that anyone on the wire who might be a member of the group cannot trust responses at all unless it also trusts the party that sent the original client C that sent the request, which is not generally the case. So we are usually assuming that there might be malicious members in the group which may then read responses, but they cannot spoof answers from any other group member. So in general, a third party cannot use those at all because it doesn't know whether the client might have sent one request to that third party, but another to the server, and then the server sent the response, and then those don't line up anymore. And this is, in retrospect, the very situation we were finding ourselves in when defining group OS core, cacheable OS core in the first place. But it might not be the only situation. So how can we salvage this? We can, as done in the non-traditional responses, just send the full request in the response again, which we want to avoid because that's we're all about saving bytes here. So repeating a request is something to avoid. We can send a hash of that request, or we could just try to make the hash of that request part of the additional authenticated data that is verifying that the server saw that request without actually transmitting that. Previous versions of cacheable OS core had that information in a modified external AED. Currently, we're more leaning towards putting that in a class I option and then not necessarily sending that class I option. But so one way or another, that information needs to wind up in the AED, and thus really, it's not replacing because the parts are still there, but practically it's augmenting the request response binding mechanism. So now the client, even not necessarily the receiver of the response, even not necessarily trusting that the server was able to perform source authentication on the request, can be sure that this response is a response created by the server for this particular request. And this deals with all the parts of cacheable OS core that are about how these two things match together. And even some of the security, kind of reviewing the security caveats that we are having in cacheable OS core, one of them just goes up to that original, just goes into that half. So the statement that we don't get freshness with cacheable OS core is really a more general statement. The statement should be that whenever we don't rely on the original request response binding, but just some additional request response binding, we lose freshness. And then with deterministic, if we use deterministic keys, we need additional considerations for how do we arrive at that deterministic request, what key material do we use to protect that request, and what does that mean for the request privacy. But the request response binding is probably a somewhat different topic, and that could be even useful for other cases. So one example, and actually the example that triggered all this, is that group OS core used to have an appendix in which it was described that under certain circumstances it might be okay not to verify the signature on a request. Now that appendix was lacking a few security considerations and eventually scratched, which is a good thing to have happened with the text that was there. But it does leave an open use case. That is, when you have a group where you're just doing requests and the client does not really have an interest in doing an asymmetric signature on a request, and on sending 64 bytes just to send a request that really any of the other clients could just as well have sent, and where the server might not even, for its regular operation, depend on source authentication. For example, because any client might be eligible to use that information, or just because the request is, the handler is side effect free. I mean, it's a GET. There's nothing wrong in encrypting the response and sending it to a party that can read it if it's the authorized party, and if not, it would just not be able to process it. But this needs very careful considerations for request response binding, and I think that all the tools that we set up in cacheable OS core can do this, and thus not only benefit cacheable OS core by becoming more readable and easier to verify, but also open up those new cases. So for me, the main questions for today are, is this a split that you would consider useful? And if so, is this something that is useful to be in the same document? I think so. I think it can be meaningfully presented in a document doing really two parts: describing request response binding in absence of source authentication and group communication, and then building on that, doing cacheable OS core. But I'd like to hear your opinions here too.
Göran, go ahead.
Yeah, I actually don't have a strong opinion here. I'm really happy that there is actually a solution to this cacheable problem, and I think that we should prioritize to make that as simple as possible to use, and whether it's useful in other instances is a lower priority in my view.
Okay, thank you.
So, but yeah, that's my input.
Any more comments or input? for Christian? Neither in the chat. Okay. And thank you for the presentation, Christian. And next is OSCOR capable proxies. Yes. Okay, so this is a relatively new work, but not a super new idea. It was also presented some interim ago, earlier this year. And to recap, you may have a proxy deployed between a client and the server. And your use case, we have examples, may need a security association between the client and the proxy. And it may be very convenient that that is based on OSCOR, especially if you are already using OSCOR end-to-end between origin client and server. You end up into something that right now it is not defined or even forbidden in the OSCOR RFC, where OSCOR is something only for the origin client and server. And definitely you cannot have something like nested OSCOR where you protect the same message multiple times. This started in the draft providing, in fact, the first use case, group com proxy, and then it was agreed to just move this content out of that because it was of more general applicability, and to have it in a separate document, which is this one. As a recap of the main use cases also described in the document, yeah, group com proxy was the first one. You want the proxy to identify the client before forwarding a request over multicast to a group of servers. Second one, in a sense, also related to group communication. You may have a server sending multicast notifications to a group of clients, all observing the same resource. And if you have group OSCOR end-to-end and the proxy deployed, clients are required to take an additional step, which means providing an additional ticket request to the proxy to make things work. And that exchange, among others, is better to be protected, for instance, with OSCOR again. And then another use case comes from the lightweight end-to-end specification, where if OSCOR is used, the lightweight end-to-end client may want to use it also end-to-end with an external application server, using the lightweight end-to-end server as a co-op proxy, basically. And here you have OSCOR both end-to-end with the external application server and internally, or hop by hop, if you want, between lightweight end-to-end client and server. So the contribution of this document is trying to update the OSCOR RFC in defining also intermediaries as possible OSCOR endpoints, so consuming the OSCOR option and OSCOR layer. And then in that meeting also double, triple, as many as you want layer protection on the same co-op message. We did have a limit of 2 layers at most in the previous version of the draft, and it was lifted out of feedback we got. Yeah, we really consider OSCOR, but what you see in the document can be applied right away also for group OSCOR. For version 0, it was presenting also at an interim. We got some early comments from Christian and Joran that were very constructive and essentially suggesting some more use cases, lifting the limit of 2 at most protections of the same message. And the main feedback was that the message processing description and notation of version 0 was way too complicated and required some restructuring that we did. As to the use cases, we mentioned also the case of a cross proxy acting as third-party service for the sake of transport indication, which is also Christian's work. A proxy as a traditional big firewall as an entry point of a network that is required to identify the exact nodes joining the network. And then we started to think, but requires much more elaboration, a case where you have a long chain of proxies and you really want to hide the position in the network of the client from most of the chain elements and the final origin server, building something like, let's say, Onion OSCOR. But we have to think more about that, though the core idea is already defined in the document. And coming to the main point in Christian's and Göran's feedback, instead, we got rid of the very complicated notation and 2 fine-grained message processing steps. And we came up with a general algorithm that is applicable right away to any endpoint in the chain. So a client, an intermediary, or a server. Now we also say explicitly that we are not defining any explicit signaling of what is happening, and we don't need to. So basically, the presence, possibly in combination of certain co-op options, is just sufficient for an endpoint to understand exactly what is going on and what to do. And a main deviation from the OSCOR RFC is that an endpoint shouldn't panic anymore if after decryption an OSCOR option is still there, because that just means one more OSCOR layer to strip. And some options have to be protected or to be treated as class E if you want, unlike the OSCOR RFC. And this includes, in fact, the OSCOR option and options intended for a proxy. So with this in mind, it's pretty easy to protect the request just applying the OSCOR layers one after the other, typically using as first one the one shared end-to-end between the origin client and the server. But things get interesting, and here's the generalized algorithm when you think of an incoming request. And based on the new text we have, it's really about evaluating which of these conditions apply to a request. So it includes proxy options, well, forward to the next hop towards the server, if this is a proxy at all. If it doesn't have proxy options and it doesn't have the OSCOR option either, deliver to the application if there is any at all. You are in case C otherwise, meaning you don't have proxy options, but you have an OSCOR option. And then, well, use the recipient context pointed by the OSCOR option, decrypt, take the result, and on it, assess which condition applies again. And eventually you land to case A or B for forwarding or delivering to the application. Omitted in the slides, but of course we have also error handling covered already. For responses, it is easier. For a responder, it is really about reapplying the same security layers successfully stripped out from the request, but in reverse order. And the recipient of a response is expected to find the same security layers it applied, but this time in reverse order, and at most as many as it applied in the request. So this is what we have now, and again, the main update was generalizing the procedure to admit right away well, a long chain of intermediaries, more than 2 layers if you want to, and to have a much simpler and easier to read message processing as a general algorithm. We have still a lot to do. We want to add examples, considering caching, but that should be possible to have just using the cacheable score proposal that Christian presented before. And we want to elaborate a bit more on a use case where having more than 2 layers per message is useful. And this is perhaps a bit longer term, but we want to look into RFC 8824 that defined another compression for co-op, also for the case when OSCOR is used. And maybe not as is, but we think that approach can be possibly adapted a bit to be used also in a case where a message is protected with multiple layers, so that we can, at the end of the day, reduce the overhead in this case too. This is the plan for version 02, but until then, comments, input are very welcome, anyone. Esko is already suggesting a name, Matryoshka, probably. We'll think about it. We were trivially thinking of OSCOR in OSCOR or nested OSCOR, but why not? Wow, unexpected. Okay, we'll seriously consider. So,
well, you need to put acronym maybe then if you want to do that.
yes. Okay, I'm actually done, and we entered the flex time just in time for the last presentation. Thank you all. And now it should be about Giuseppe.
Hello?
Hi, I can hear you.
Okay, good. I have to present by myself, right?
Yes, if it works for you.
Yeah, yeah. Let me find it. Yeah.
Perfect.
Okay. Yeah, hello everybody. This is a new work about the co-op performance measurement option that we have proposed as a 0.0 version for this meeting. Yeah, first of all, let's explain the motivation for this work. So you are, of course, the expert on COPE, and you know that there are two modes, reliable mode and reliable mode. In case of reliable mode, reliability is provided with acknowledgement, so because the message is marked as confirmable. In this case, we can think that if we want to implement some measurement, we can use the message ID and acknowledge to identify the packets and measure round trip time to verify losses. This can be done in case of reliable mode. In case of unreliable mode, of course, this is not possible, and this is no easy way to do measurement, round trip time, losses, delay measurement. In any case, even if we are in the reliable mode, it is resource consuming to read ID, sequence number, store timestamps for each packet. So, and since we are in a constrained environment with constrained nodes, this is not the best way to implement measurement in constrained environment. So we need to find a simplified mechanism. Yeah, I go to the next slide. So it is not new in IETF. There are already some mechanisms that are also called explicit flow measurement. This is a draft that has been just adopted in IPPM working group, and the techniques described in this draft employ a few marking bits inside the header of a packet for loss and delay measurement. In particular, I want to start with the two idea. One is the spin bit idea. This is already optional in quick protocol. So if you go to the RFC 9000, there is the 1 bit that is dedicated for spin bit. So the spin bit idea is to create a square wave signal using a bit, and the length of this signal is equal to RTT. So you can understand that in this way, this is very straightforward to measure the delay, because you only need to measure the length of a square wave. So you don't need to take timestamps. So you need to take timestamps, but only for few packets, not for every packet. On the other hand, there is also another technique that is based on square bit. Also, in this case, the idea is not new, so it is also known as alternate marking methodology defined in the RFC 8321. Also, in this case, we are talking about square waves, but in this case, the square waves is made of a fixed number of packets. In this way, this fixed number of packets can be recognized between the client and server, and you can measure the losses. Just to give a quick view of these two methodologies. So what we are proposing now, we are proposing, thanks to the extensibility of co-op, the draft aims to define a new option carrying these performance measurement bits. In particular, we can start with spin bit and square bit that are, let's say, the most stable solutions, because, as I said, spin bit is already defined for quick, while square bit is already defined for IPv6, for SRv6. So there are already a lot of proposal about the alternate marking application. So the proposal for this option is quite simple. So we introduce two kind of patterns. One that include only the square bit, the other one include the square bit and spin bit. In both cases, we have added, let's say, to complete the byte available, we have added some event bits that can be used for advanced usage of this option. What are the key points and benefits of this solution? So the first one, as I said, is that no sequence number, no IDs, no sequence number, no time stamping for each packet. So there is an easy way to measure FTT and delay and the round trip time that fits well with the requirement of constrained nodes. There is also a proposal to improve the square bit mechanisms to find the synergy with spin bit in order to need the methodology simpler, but I don't want to explain this here because it is mentioned within the draft, and maybe we can discuss on the list, or I can present during the next meeting if the idea is of interest of the working group. And once you are able to do performance measurement, you can also think about possible advanced usage of this methodology. For example, an on-path observer that can be a probe, a gateway, or a proxy can use this information to adjust, for example, protocol parameters, or to decide whether to use reliable or unreliable message transmission based on the conditions of the network. So you can also think about this kind of advanced usage. So yeah, the next step. The draft is based, as I said, on well-known methodologies that we had this idea to extend in this kind of environment, because these methodologies can be easily extended to constrained environment. And considering that IoT, machine-to-machine devices keep growing nowadays, also the performance measurement aspect is something to be considered for an enterprise, for a network operator that want to use co-op protocol in the constrained environment. So, okay, it's just a proposal for discussion. So we welcome collaboration, questions, comments on this work. So that's all. Thank you.
Christian, go ahead.
Thank you for presenting this here. You mentioned also in the response to previous communication that you would, and here again, that you would like to use this across proxies, so that the spin bit would kind of be set by the client and then be not modified by the proxy and then sent to the server, or other values of that option. Could you briefly describe which parties would all need to cooperate here? Because I understand this to be coming from a telecom background, and the kind of would this be implemented on all those devices, and which components would then, can you give a concrete example of which devices interact here in a proxying situation? Because my impression is that when proxies are involved, it could really be link local, and then things like Carsten suggested, use of MID could come into play. But first, I think we should understand how you intend this to be used with proxies.
Yes. I mentioned in the reply that there are several ways to use this methodology, because since it is based on the client server, so it can be applicable to the session. So, for example, if the proxy is going to start a session on behalf of the client, of course, the proxy can be, of course, the client in terms of the measurement. So it depends on the situation that we we want to monitor. So I think, for example, based on your comment, I think that we have to further clarify the user scenarios that we have in mind in the next version of the draft, in order to say, okay, if there is a proxy, the way to do measurement is that. If there is no proxy, client server can implement the measurement. So we have to distinguish between the different situations. So thank you for the comment, because we can surely improve the next version of the document. Yeah.
Thank you, Giuseppe. We may have time for one more quick question, because we are really on top of the hour. Any more questions or comments? I hear none and see none in the chat, so we can adjourn the meeting. Thank you very much for participating today and for your hard work. Enjoy the rest of the IETF week. See you all in Gather Town.
Thank you.
Thanks a lot to the news takers.
Thank you.
Thanks, bye-bye.